Welcome to the deep dive. Today, we're really getting into something pretty critical if you're aiming for that senior software engineer spot.
Yeah. What do we got?
We're diving into distributed database architecture, specifically that combination of replication and partitioning.
Oh, okay.
Yeah.
Yeah, that's a big one. Can definitely feel like a lot to wrap your head around.
Totally. So the goal today, our mission, if you will, is to kind of pull out the core ideas you really need to get,
Yeah.
especially for those technical interviews, right?
Right. Think of it as maybe a shortcut to understanding these key pieces.
Exactly. So starting point,
Mm.
big database, lots of data, lots of users. What's the first step?
Well, you pretty much hit a wall with a single giant database eventually. It just doesn't scale.
Right.
So the fundamental idea is you have to break it down, make it into smaller, more manageable chunks.
That's partitioning or sharding.
Exactly. Partitioning or sharding, you hear different names for the pieces depending on the system, like shard or region or tablet.
Or Vinode, vBucket.
All those. But the core idea is the same. Divide the data up. It makes managing it, scaling it, just way easier.
Okay, so you split the big book into smaller volumes. Makes sense. Easier to handle.
Mm-hmm.
But just splitting it isn't the whole story, is it? Like, what if one of those volumes disappears? A server fails.
Yeah, good point.
Yeah.
That's where replication comes in. Super important. You absolutely need copies of your data.
Multiple copies.
Multiple copies spread across different machines, different nodes. So if one machine, has a problem, takes a nosedive.
You still have the data somewhere else.
Precisely. So partitioning helps you scale out, handle more load. Replication gives you that safety net, that fault tolerance, keeps your data safe.
Okay, so we need both. Partitioning for scale, replication for safety. Now, the bit that seems to come up in, like, the more senior level chats, the interview questions,
Yeah.
how do they actually work together? Because it's usually not just one or the other in real systems, right?
No, not usually. In a lot of modern distributed databases, the nodes, the individual servers, they often wear two hats.
Two hats. How so?
Well, a single server might be the leader for some specific partitions. That means it handles all the writes, the changes for that chunk of data.
Okay, the boss for that data.
Kind of, yeah. But at the same time, that very same server could be a follower for other partitions.
So it's taking orders for other data chunks.
It's replicating data from the leaders of those other partitions, so it holds copies, keeps up to date. This dual role is really key.
Huh. Okay, so it's not like, here are the leader servers and over there are the follower servers, totally separate.
Nope. It's much more interwoven. Helps balance the load and use the resources efficiently.
Right, right. Can you maybe, like, walk through a simple example, say 4 nodes?
Sure. Yeah, 4 nodes, 4 partitions is a good way to picture it. Imagine node 1 is the leader for partition 1.
Okay.
But it's also a follower for, say, partition 2 and partition 3. It's getting copies of their data. Got it. Leader for 1, follower for 2 and 3.
And then maybe node 2 is the leader for partition 3, and it's a follower for partitions 2 and 4.
Okay.
Node 3, maybe it leads partition 2 and follows 1 and 4.
Right.
And finally, node 4 leads partition 4 and follows partitions 1 and 3. See how leadership and followership are spread out.
Yeah, I see. Every node is doing a bit of both.
Yeah.
Okay, so if my app needs to write something to partition 4, where does that request go?
It goes straight to node 4, because
Yeah.
node 4 is the designated leader for partition 4.
Makes sense.
So node 4 gets the write, processes it, updates its local copy of partition 4, and then
And it tells the others.
it immediately starts replicating that change. It sends the update through replication streams, usually to its followers.
Which in our example were node 1 and node 3.
Exactly. So nodes 1 and 3 get the update for their copies of partition 4, keeps everything eventually consistent and redundant. Okay, that clarifies the flow. Writes to the leader, leader replicates to followers. So zooming out, what are the big wins here? Why is this combined approach so important, especially for, us aiming for senior roles?
Well, the benefits really tackle the core problems of big, reliable systems. First off, load distribution.
How so?
By spreading the leadership for different partitions across all the nodes, you're also spreading out where the right operations have to go.
So no single node gets hammered with all the writes.
Precisely. It prevents bottlenecks, especially when things get busy. Different partitioning schemes like, hashing, try to spread this load evenly, though sometimes that affects other things like range queries.
Right, trade-offs everywhere. Okay, load distribution, that's huge. What else?
Next up, fault tolerance. This is critical.
Because of the replication part.
Exactly. Each partition is copied onto multiple follower nodes.
Okay.
So if the leader node for a partition suddenly fails.
Like node 4 in our example goes offline.
Yeah. If node 4 dies, one of its followers, like node 1 or node 3, which
Yep.
have a recent copy of partition 4's data,
Can step up.
can be promoted to become the new leader. There's usually a quick election process. This failover means the data is still available, and writes can usually start again pretty quickly.
Okay, so the system can heal itself? Kind of. That's vital. What about just growth? More data, more users.
That brings us right to scalability. This whole architecture is built for it.
How does adding nodes help?
You can scale horizontally. Just add more servers, more nodes to the cluster.
And
Then you can redistribute the partitions, move some partitions and their leadership roles onto the new nodes. It lets the system handle more data, more traffic, without needing one super powerful, expensive machine. You just add more standard ones.
So you scale out, not just up. Nice. And you mentioned 4 benefits. What's the last one?
The fourth one is high availability.
Isn't that similar to fault tolerance?
It's closely related, but focuses more on keeping the system accessible, especially for reads, because you have replicas on different nodes.
Right, the follower copies.
Yeah. Even if the leader node for a partition is down, maybe during that failover period we mentioned, or even if multiple nodes fail.
Other nodes still have copies.
Right. The surviving follower replicas can often still serve read requests. So users might still be able to view data even if writes are temporarily paused for that partition. It minimizes perceived downtime.
Okay, low distribution, fault tolerance, scalability, high availability, those are definitely the big requirements for any serious application. Makes sense why understanding this is key.
Absolutely.
We should probably clarify something quickly, though. When we say partitioning here,
Uh-huh.
we mean deliberately splitting the database data, right, for scale and management.
Yes, exactly. It's a logical division of your data set, a
Wow.
design choice.
It's not the same as a network partition.
Oh, definitely not. That's a completely different beast. A network partition or a net split, that's a failure. It's when the network connection between nodes breaks down.
Right. It causes all sorts of different problems. Consistency headaches.
Huge headaches. Yeah, that's really a separate topic, how systems handle network failures. Important, but different from database partitioning itself.
Good distinction. And just to double check, even though partition 4 in our example exists on node 4, node 1, and node 3, any single piece of data, like one user's record.
It belongs to exactly one partition,
Yeah.
logically.
So my user info isn't somehow split across partition 1 and partition 4?
No, no. It lives in partition 4, or whichever partition it hashes to or belongs to based on the key range. That partition, partition 4, is then replicated to nodes 1 and 3 for resilience. But the data itself has one primary home partition.
Got it. That clarity is important. It really drives home why knowing the stuff isn't just like academic. It's fundamental to building systems that actually work at scale.
It shows you understand the why behind the architecture, not just the what. It's about designing for reliability and growth.
So when you're faced with building a new system, how do you even decide? Just partition, just replicate, combine them? Ah, well, that's the engineering part, isn't it? It depends. How much data? How much traffic? How critical is uptime?
What can you afford in terms of consistency versus performance?
Exactly. What are the trade-offs you're willing to make? For anything reasonably large, needing high availability, you pretty much always end up combining partitioning and replication. The complexity is usually worth the benefits.
Yeah, feels like the default for serious stuff now.
Yeah.
And it's kind of cool to remember this isn't brand new tech either.
Oh, yeah.
Like NoSQL and Hadoop definitely popularized these ideas recently.
Yeah.
But the core concepts of partition databases,
Yeah.
they were being worked on way back, like in the 80s.
That's right. Trying to handle massive data sets even back then. So these patterns are pretty well tested, refined over time.
Yeah, stood the test of time. Okay, so let's try and wrap this deep dive up. Key takeaway.
Yeah.
It's this blend, right? Partitioning lets us scale out, handle big loads by dividing the data.
Mm-hmm.
And replication makes sure the system is robust, can handle failures, keeps data safe by making copies. And the clever part is how nodes often do both jobs, leading some data, following others.
That dual role. It distributes everything, the data, the write load, the replication work.
Which gives you those big wins. Load distribution, fault tolerance, scalability, and high availability. Foundational stuff for distributed systems.
Definitely. So for everyone listening, especially if you're prepping for interviews, really try to internalize this combined approach. Think about the why.
Yeah, the reasoning behind it.
Okay, so here's a final thought to chew on, something to think about after this. Given this architecture, leaders handling writes, followers replicating, What are some of the really tricky challenges in keeping the data consistent across all those replicas?
Ooh, good one. Especially when lots of writes might be happening close together, maybe even concurrently.
Exactly. And how might different ways of doing the replication, like synchronous versus asynchronous replication, how might they try to solve those consistency puzzles?
What are the trade-offs involved there
Uh,
between consistency, performance, availability?
yeah. Lots to think about in terms of keeping data accurate in a busy, distributed world. Definitely worth exploring more. Thanks for joining us for this deep dive.